Hello, welcome to this presentation on the basics of capturing video of human and animal performance, locomotion, actions, and activities. There are many scenarios where we would like to visualize or understand how movement occurs. It may be an athlete we are coaching, a patient with a gait abnormality, or just capturing a video of our child or loved one who's doing something we want to remember. My name is Rob Gillette. I have been studying performance and locomotion for over 30 years. A large part of this effort is capturing video of the subject while they are performing their event or are moving in a manner that allows for fundamental analysis of their musculoskeletal system. The most important aspect of video analysis is to capture a good, clean video in the first place. If the video is not good, it will hinder our ability for analysis or won't be a good representation of the event. The first step that should be understood is that the event should come first in our planning and settings. If we are capturing an athletic event or specific activity, we may only get one shot at it. This is different from having the subject sit and or pose for a picture or directing them to perform certain tasks as in a cinema movie setting. In this presentation, I would like to review some tips for capturing videos for analysis, some useful camera settings, using phones or tablets for capturing video, and ways to play back and analyze captured videos of action. Many research or study centers will have high-level professional video analysis systems that can be very costly. These systems are needed to analyze the micro, macro, and finite body actions involved in movement. They may capture from multiple views at one time, may capture at very high frame rates. The cameras may be synced into a computer system, and the subject's body movements may be digitized into quantifiable values in a database. These systems allow researchers, doctors, coaches, or trainers to fully understand how the subject's body is moving in relation to the activity in question. Although these systems are great for acquiring research-level information, they are not necessarily usable for most field operations and are too cumbersome for everyday athletes, coaches, trainers, or those just wanting reliable basic information. Recent advances in video technology over the past 20 years have produced new devices and related applications that can be very useful by most anyone who has an interest in capturing video of athletic, working, or other similar activities. Devices that can be used today include small digital cameras, cell phones, or even tablets. Video captured by these devices can then be played back for use by the coach, clinician viewing, the client or owner, athlete viewing, or can be played back on a computer, tablet, or phone. It is somewhat different than the typical photography or videography. In capturing action video, it is important to recognize the focus is on capturing the subject in the action. We are not going to pose the subject. We will only get one shot at catching the activity. Subsequent activities may be different related to speed, experience, or environmental changes. Also, the subjects in action video are moving fast, and parts of them are moving faster. Many times, from a coaching or clinical standpoint, we will need to see how the body's components move to best assess locomotion. The goal is to capture the components of action that occur in a very short period of time. Many times, these may be milliseconds. The camera settings related to this are the frame rate, shutter speed, aperture, and ISO. A high frame rate is needed to increase the number of frames captured during the activity. A higher shutter speed will help to sharpen the images captured during the activity. The settings most related to brightness or exposure are shutter speed, aperture, and the ISO. To get the best images in video, it helps to understand how the device captures the images. The camera captures images onto a sensor that transforms the image into a data file. The lens adapts the image to fit onto the sensor. The shutter controls how the image light passes onto the sensor. The sensor turns on and captures the image and transfers it to the hard drive. The sensor also will send an image to the device viewer. The frame rate, or pictures per second, is the rate that the sensor can capture images. Historically, video was acquired at 24 or 30 frames per second, 1/24th or 1/30th seconds per frame. Today, many videos are taken as pictures per second. FPS is the number of times the sensor is turned on per second. Increasing the FPS, 60 up to above 120 frames per second, allows to capture more movement actions. This slide shows a sequence of images or pictures taken from a video captured at 30 frames per second. If I was wanting to analyze this video and say I want to analyze the surface contact of the left front leg, I would really only be able to look at 3 of the frames that had anything to do with the left front leg being in contact with the surface. This slide has a sequence of images from a video that was captured at 120 frames per second. So you can see in this sequence, if I'm wanting to analyze left front support, or the support phase of the left front limb, in this sequence I got 12 images that I could use. So I'm better able to understand what's happening within the contact phase of that left front limb. There are a couple of ways that a sensor can capture an image, typically termed rolling versus global. Rolling is when the sensor turns on from one point of the sensor to another. Global is where the entire sensor turns on at once. In a rolling sensor, as it comes from top to bottom or from the middle out, movement can occur while that sensor is actually trying to capture. So sometimes you'll see a blur or a distortion of the image itself. As you can see in the picture on the top there, the limb looks like it's bent or curved, when in reality the limb would not look like that. Shutter speed is how long the shutter is open and allowing light to meet the sensor. Normal is 1/60th per second, or 2 times the frame rate. Action videography needs at least a 1/250th second shutter speed, depending on the animal's segmental velocity. 1/500 or 1/500th works for animals in a trot, which prevents blurring. 1/1000th will get most high-speed action shots of the limbs. These are examples of how a shutter would be open. In the top line, a shutter would be open very quickly, and then it gets slower as you get down. So in a sense, you could say this is 1/500th, 1/250th, or maybe 1/60th of the shutter speed. This is an example of a video where the shutter speed was too slow, blurring the leg movements during the swing phase. When I stop the video, you can see that the limb going through the swing phase is blurry. So it's real hard to understand what's happening to that limb. I do want to thank Sean Harris and his dog Finn for allowing me to use this video for this presentation. I prepared this slide to show the variances in shutter speed and frame rate. These two settings can be confusing. In the top 2 rows there, we have 2 different frame rates. In other words, one of them is twice as fast as the other. In the bottom 2 rows, we have the same, we have 2 different shutter speeds. So the shutter speed is slower on the top of the bottom 2, and slower in the bottom of the bottom 2. So you can have an alteration in frame rate and an alteration in shutter speed. Typically, you want a very tight, quick shutter speed for action videography. Here we have an action video where it was taken at 30 frames per second and a 1/500th shutter speed. As I go to stop the video in mid-action, there's minimal blurring there. So in this case, this is where the quicker shutter speed allowed for an understanding of the movement much better than in the blurry video. A high frame rate and high shutter speed will need much more light reaching the sensor because there is less time for it to capture. We can use the sensor exposure triad descriptor to help illustrate how we can brighten up the capture. Since the shutter speed acts to darken the image, we can use the other two settings to adapt. We can increase the aperture and ISO to help brighten the image. We want to capture the best image to view the activity. Typically, we will select a fast shutter speed. 1/500th is good for many actions. 1/1000th may be needed for very high-speed activities. The aperture is related to the opening of the hole in the iris, or the aperture. A small opening will result in focusing on the depth of the image. A large opening will need to be focused on the subject you are trying to capture. The ISO is the International Standard Organization standard for measuring light. It is related to image sharpness. The higher value can appear very grainy when compared to the lower values. Since the subject is moving, which can in itself create image blurring, and if we want to minimize blurring of the image, it is important to eliminate or minimize any camera movement during the capture. Moving the camera will have the same effect as subject movement and can make it even worse. If possible, keep the camera in one position. Try not to move it during the capture. A tripod or any other stability device can be used. If you need to pan or move, try very hard to move smoothly and in the same direction as the subject's actions. It is important to maintain a stable camera and to practice this skill. Here are some examples of how a camera's movement can affect the image captured. In scenario A, the stable cameras in proper settings allow for blurring of the subject. In scenario B, the stable camera's proper settings minimizes blurring of the subject. And in scenario C, an unstable camera with the proper settings results in blurring of the subject. So it's very important to maintain the stability of the camera. Once the video is captured, we will need a media player to play it back for review. Video is typically played back at a rate of 24 or 30 frames per second, depending on the media player. This means that video captured at a higher rate will appear to be in slow motion. Since a video is actually a series of individual pictures, it can be stopped and a single frame can be viewed. If we use the correct shutter speed, we can then evaluate the action with minimal blurring. So this is a high-speed video of a greyhound running, and you can see that when I do the stop action, there's minimal blurring of the limbs. There's some, but minimal. It is very nice to use a player that can play any video back in slow motion and can stop the video at one frame. This is really helpful for the coach or clinician when demonstrating or explaining the intricacies of movement to the subject. If they can save the video for later viewing in any media player, that is also very helpful. The SPVS app is one system that is designed specifically to capture and play back a video in slow motion. You can also save this video in a slow motion video format for viewing elsewhere. So here we'll try and stop the video, move it back, move it forward. It allows us to better understand what's going on during movement. Slow motion playback of a video that has been properly captured allows for analysis of performance and athletic potential, can be used to assess conformation characteristics. It can be used as a diagnostic tool for lameness evaluation, and can be used to evaluate effectiveness of therapy and rehabilitation. We can use many devices to capture video. Here we see a digital point-and-shoot camera, an iPad, 3 different Android tablets, and an Android phone. Cameras, tablets, or phones can be used to capture and play back videos. They can either be viewed on site or later for analysis. This allows for types of analysis that has not been possible in the past. Just to review, It is very important that the captured video is of good quality, as we cannot change it once it is captured. We will need to set the capture camera up appropriately, as we may only get one chance to catch the action. To prepare to capture action video on a camera, tablet, or phone, try to find the manual settings. The frame rate should be 30 frames per second or higher, preferably 60 plus if available. Some devices won't have that option, but will have an action or activity setting. The shutter speed should be 1/250th of a second or higher, preferably 1/500th speeds if available. Again, some of these devices won't have that, but may have an action or activity setting that you can use. Lighting is important. Indoors, the aperture should be set at f4 or f2, and the ISO should be set at 1600 or 3200 plus. If outside, the lighting should be fine, but test for the best F and ISO settings. There are many media players that can be used for playback. Some common players are VLC Media Player, and that is free. Windows Media Player and Media Player Classic are also commonly used in Windows. QuickTime Player is the built-in player for the iPhone and iPad. SportsVet Performance Systems app for Android tablets, phones, and iPads or iPhones is another option. It is an app developed specifically for coaches, trainers, doctors, veterinarians, or other professionals who work with athletes, dogs or horses, or individuals who have an interest in action videography. In this presentation, I have covered some of the main items that I have found to be important when I am capturing action videos for analysis. I cannot tell you how many times people have asked me how I get the good action videos that I present. It took a lot of practice and researching videography over the years. I do not declare to be a videographer by any means, and will defer questions on high-level video capture to those professionals. I am just a veterinarian who uses biomechanics for his studies in the performance sciences. I'd like to thank you for taking the time to watch this video, and hopefully you find this information useful. Good luck in your future action video adventures.